Good morning, Algebra 1. This is Mr. Rabuzzi, joining you here in virtual Brashear. I have all your lockers set up, your books in your virtual bags, so everybody should be ready to learn today. All right, before we get started with the lesson, I'm just going to talk about our question and what we're going to learn about this week and next week. So we're starting Chapter 7, and Chapter 7 asks us what strategies can be used to simplify algebraic expressions containing exponents and radicals. So today we're going to start with the exponents part, and we're going to learn a little bit about exponents and how to deal with them, how to simplify them. So let's get started. Okay, so here at the first board, we have a little bit of vocabulary and maybe some review. So on the board, I wrote out a monomial. See, here's the name. A monomial could have more than one number in it, more than one variable too. We have a 4, an x, and a cubed, so 4x cubed, but all together, this is one term, okay? So let's break it down into pieces, though, to talk about the different vocabulary words. First, we have this 4 in front. It could be a 10. It could be 100. It's just a number in front of the x. They are multiplying together, but this is called the coefficient. Okay? The coefficient is the number in front. And notice the coefficient has no exponent. Okay. Next piece is a variable here. It could be x, y. It could be x and y. You could have an x and later a y. So it could be more than one letter, but right now we have one letter, and this is our variable x. But because it has an exponent, it has a different name. This is called the base. Okay? And finally, we have an exponent up here. So we already know the name. This is called an exponent, but it has a different name too. Sometimes you hear it called a power. So we have our coefficient, a base, and an exponent. This is the simple version of a monomial. If you look over here, here's an expanded version of the same number. We look the same things. 4, 4. X, x. To the third power. So we have 3 x's. Okay? So these are the same number, the same term. This one is expanded, and this one is simple. So this is what we want when we solve problems. We don't want this. Okay, that's our vocab for today. Let's move on down to the next board. Okay, let me get the camera set up. Perfect. Okay, here we have a practice problem that we can look at. So now that we know what a monomial is, I have 2 here. This is one monomial, and this is one monomial. And I want to multiply. So I know that I'm multiplying because I have a parentheses next to a parentheses. That means multiply. So I'm going to break it down into pieces to multiply. First, I know how to do -4 times 3. So -4 times 3, -4 times 3 equals -12. Okay? So that's our coefficients multiplied. Now we can move on to one of our bases. So I'm going to start with this a. We have an a base here. Do I have another a base? I can only multiply bases together if they have the same letter. So we have a and a. They can multiply together. So we're going to get a, but when I multiply the bases, here's the secret. Add the exponents. So instead of doing multiplication, I need to do 3 plus 2. So it's going to be 3 plus 2, which is a to the 5th. Okay, that's our first base finished. Now look, we have another base. We have this b, and we have a b. So these have the same base letter, b and b. They can multiply together. So let's do it. B, what? Hold on. This b has no exponent, right? If there's no exponent, we can put a 1. It always has a 1. Okay, so we're going to get b 1 plus 5. 1 plus 5, because when we multiply monomials, the b and the b are multiplying, so the exponents get added instead. 1 plus 5, so we have b to the 6. Okay. Then let's put it back together. We have 12. Oh, negative 12. Negative 12. We have a to the 5th. A to the 5th. That's an A. And we have b to the 6th. B to the 6th. There's my final answer. That is the simplified version of our starting multiplication. Okay, let's do one example from the packet. And remember, if you can't keep up with the notes, you can always look at this later. There will be a video of the same thing. Okay, so in the packet, after the warm-up page, there's a page of practice problems. This is number 3 from that page. So this one says we have negative 7x squared times x to the 4th. Okay. So just like the last one, I want to start with my coefficients. This one has a coefficient negative 7, and this has nothing. So, okay, negative 7 and nothing. If there's no coefficient, it's 1. We know that, the invisible 1. So, negative 7 times 1 equals negative 7. Okay. Finished with the coefficients. So let's look at our bases. This base is x. This base is x. Good. Same letter. They can go together. So we're going to get x. But what is our exponent? Is it 2 times 4? We're multiplying. No. When we multiply the monomials, we add the exponents. 2 plus 4. So it is x to the 6th power. Nice. Now we just need to put it back together. So negative 7 x to the 6th. Final answer. That is the simple version of what we started with. Simplified. All right. So that is multiplying monomials. If they have the same base and they're multiplying, you can add the exponents. Okay, last board for today. Now, we have some problems where we have a power of a power. So look at my example here. We have a nice monomial, has an exponent, and here we have another exponent. Oh, this 3 exponent is the power of a power. Power of a power. And what that means, because it's on the outside of the parentheses, it needs to be distributed. So it's going to go to that 2, the negative 2. It's going to go to that A, and it's going to go to the B. Okay. Again, let's start with the coefficient. We have a coefficient, negative 2, but it is now negative 2 cubed. Negative 2 cubed. Okay. That means negative 2 times negative 2 times negative 2, which is negative 8. All right. Nice. Now, I'm going to untangle. And let's look at the first base. Our first base is this A. It has no exponent. Gotcha. It's a 1. Exponent 1. Okay. Now we see we have A to the 1 to the 3. So it's power of a power. We multiply. So it's going to be A to the 1 times 3 times 3. 1 times 3 is 3, so it's just A to the 3. Okay? So let's check it by looking at the last base. We have a B for our base. This B has 2 as an exponent and a power of a power of 3. Power of a power means multiply. So we're going to get B to the 2 times 3. 2 times 3, which is B to the 6th. Okay? Now we just need to put everything back together. Everything. We have negative 8. We have A cubed. And we have B to the 6th. There it is. Final answer. Okay, so it's not too bad. Let's check one example. Okay. Yes, we have time. Okay, so this is an example from the packet. This is on, so if you go to the page with the warm-up, the next page, and then the next page. So second page of practice problems. This is number 2, I think. 2 from that page. And it says negative 3 times AB to the 4th. So A, B to the 4th. Close the parentheses, cubed. Okay. So I'm going to look at the coefficient first. This negative 3, it's a coefficient. That's true. But it is outside the parentheses, right? It is out here. So it's safe. It does not need to worry about that power over here. This 3 only goes to the parentheses. This negative 3 coefficient, it can just come down to the next step. It's finished. Nice. Now we need to move into the parentheses. We have a base, and we have a different base, and we have our power of a power. So it's a power 3, needs to go distribute to the A and distribute to the B. Okay, let's look at the A first. A has no exponent. Gotcha. That means 1. So, power of a power, multiply. So it's A 1 times 3. 1 times 3, which is a cubed. Okay. Then let's look at the b. b has a power 4 and a power of a power 3. So we need to multiply. b to the 4 times 3, which is b to the 12th. Okay. Then we have all of our pieces. Let's just put them back together. We have -3 coefficient. We have base a to the 3rd and a base b to the 12th. Finished. Okay. One more example. Check the time. Yeah, we got a minute. Okay. So this is the same page in the packet, but this one is number 4. And it says, parentheses, 4x, parentheses, squared. Then, parentheses, b to the 3rd. Ooh, that was a long parentheses. Okay. So, let's start with we have a power of a power. This 2, it's a power of a power, right? It's outside the parentheses, and it needs to go to both of the pieces. Okay, let's start with the 4. That's our coefficient. So the 4 is going to be squared. 4 squared, which is 4 times 4, which is 16. Okay. Coefficient is finished. Let's check the first base. We have a base x. It has an exponent. You're right. That's an invisible 1. So, power of a power, multiply. So we do x to the 1 times 2. 1 times 2, which is x squared. Okay. Did we change the b? Do we need to change the b? Right now, it's a b for the base. Well, it has a base b and an exponent of 3. And there's no power out here. So we're good. All we need to do, bring it down for our final answer, hopefully. So let's check. We have this all coming back together. 16 x squared and b cubed. Okay, we can check if we need anything else to do. Do we have any double bases? Do we have another x anywhere? No. Another b anywhere? No. Do we have a power of a power still? We have a power, and we have a different power, but it's not like here where it's outside the parentheses or stacked on top. So this is all finished. That is our simplified version. Okay, so it is now time for our question and answer.